Pulse amplitude modulation or PAM. Okay. Now, pulse modulation or analog modulation system, we know that in analog modulation system some parameter of a sinusoidal carrier is varied according to the instantaneous value of the modulating signal. In pulse modulation method, the carrier is no longer a continuous signal but consists of a pulse train, some parameter of which is varied according to the instantaneous value of the modulating signal. So that is the concept of modulation. Okay, so there are two types of pulse modulation. Pulse modulation is of two types: pulse amplitude modulation or PAM, and pulse time modulation. Or PTM. Now, pulse time modulation is further classified into two types: pulse width modulation or PWM, and pulse position modulation. Or PPM. Okay, now suppose the carrier signal is this. Okay, okay, so this is the modulating signal xt. This is time t. Now PAM signal will be pulse amplitude modulation. Here is 0. Here the modulating amplitude of the modulating signal is 0. So the pulse signal will also be 0 here. Here will be some value. This, and here is also some value. This. There is also some value. Okay, so this is 0. So this is PAM signal. T. In case of PWM, the width of the pulse train is varied. Suppose this is the original width, because the amplitude of the modulating signal here is 0, and this is some this is the maximum value. Here is also value is maximum, so width will be expanded here. Okay, here less expanded with is less expanded, right? Here is also the width will be very small as compared to the original signal. Here is also, because it is more negative, so this is also very small width. Okay, so this is pulse width modulation, PWM signal. This is T. Again, in case of PPM, pulse position modulation, suppose the signal is middle here. The amplitude is nearly maximum, so width will be shifted. The signal width will be shifted towards the right. Here is also towards the right. Okay, here is also some extent in the right. Okay, now in this case the value is negative. Modulating signal, the amplitude is negative. The amplitude is negative, so here will be it is left shifted. The signal is left shifted here. Here is also left shifted. The signal is left shifted, right? So this is PPM signal. Okay, now generation of pulse amplitude modulation. Generation of PAM. PAM signal is basically the sampling of the continuous time modulating signal. Okay, so there are two types of sampling used here. One is flat top sampling, another one is normal sampling. In flat top sampling is mostly used. The circuit diagram to get flat top sampling is this, using two MOSFET and one capacitor here. This capacitor is called bypass capacitor, as we know in communication. Okay, so this is the sample output GT. Here is XT. Okay, and there are two gate terminals. This is G1 and G2 gate terminals of two MOSFETs. Okay, so as we know, MOSFETs are used as a switch, so this is sampling switch, and this is the discharge switch. Right, this is the discharge switch. So we are getting flat top sampling here. Suppose the modulating the waveform of the modulating signal is this, then the flat top sampling looks like this. So this is flat top sampling. This is the original modulating signal XT, and this is the pulse signal GT. So this is flat top sampled circuit. Now demodulation of PAM. Demodulation of PAM. Okay, now the block diagram of for the demodulation of PAM consisting of a holding circuit, and another one is a low pass filter. Or LPF, right? So the input is here, received PAM signal, and the output is demodulated signal. So demodulated signal is the output. So this is the demodulation block diagram for demodulation of PAM signal. The demodulation is the reverse process of modulation in which the modulating signal is recovered back from a modulated signal. For pulse amplitude modulation signal, the demodulation is done using holding circuit. Okay, so this is the holding circuit, right? And there is a low pass filter.